running at an initial velocity of 1.5 meters per second accelerates at a uniform rate of 0.5 meters per second squared. Calculate the time taken for its velocity to increase to 6 meters per second. Pause this video, solve this problem, and when you are done, you compare your answer with mine. Alright, let's solve the problem. What's the first step? You read the question carefully. That's done. Second step, you list out the parameters you have. A boy was running at an initial velocity of 1.5 meters per second, accelerate at a uniform rate of 0.5 meters per second squared. Calculate the time taken for its velocity to increase to 6 meters per second. Which formula would you use? The first equation of motion. This is direct. V equals to U plus A T. Let's substitute our values. What's our V? V is 6. What is U? 1.5. Plus A. What's our A? 0.5. AT. 0.5 T. 0.5 multiplied by T. So 6 is equals to 1.5 plus 0.5 T. The first step is to move your 1.5 to the left hand side to meet the 6. You know the sign in front of 1.5 is plus because it's not written, so it's plus. So when you shift it to the other side, it changes to minus. Let me finish it here. So you have 6 minus 1.5 is equal to, on the right hand side, 1.5 has left, we have only 0.5. 0.5. 6 minus 1.5, 4.5 is equal to 0.5 T. That also means 0.5 T is equal to 4.5. To find T, we divide both sides by 0.5. 0.5 we cancel 0.5. What is left? We have T is equal to 4.5 divided by 0.5. We have 9 seconds. That's all. You have to solve this question. A tricycle traveling at a velocity of 2 meters per second accelerates uniformly for 1 minute till its velocity became 5 meters per second. Calculate the distance traveled during this 1 minute. How would you solve this problem? Pause this video and solve this question. So when you are done, you compare your answer with mine. Okay, let's solve this problem. A tricycle traveling at a velocity, it was traveling at this velocity before it accelerated and got to this value. That means this is the initial velocity, 2 meters per second is the initial velocity, and 5 meters per second is the final velocity. So let's list out the parameters we have. We have the initial velocity is equal to 2 meters per second, accelerate uniformly for 1 minute. Accelerate, we are not given the acceleration. For 1 minute, we are given the time is equal to 1 minute. The 1 minute is equal to 60 seconds, right? So we have 60 seconds here for the time. The velocity became 5 meters per second. So the final velocity is 5 meters per second. Calculate the total distance traveled. Total distance traveled is unknown. Which equation of rectilinear motion would we use to get the distance traveled? So you remember the 3 equations of rectilinear motion. So here we have U, A. We don't have A here. We don't have S. The question does not say we should calculate the acceleration. We are just not given the acceleration. We are not given the acceleration in the question. We are not asked to calculate the acceleration. We are asked to calculate the distance. Let's calculate the distance traveled. Okay. U, T, V, S. U, T, V, there's no S. U, T, there's no V. U, there's no T. So which equation would you consider to be appropriate here? You know, none of these seems to work. So one way to do this is to find the acceleration so that you can use this equation. You know, we don't have the acceleration in the question. We don't have the acceleration in the question. So you could find the acceleration so that you can have a value for A. So first of all, let's start by finding the acceleration. So once we get the acceleration, we put that into this, then we're able to use this second equation of rectilinear motion. Let's solve that. So we can take this, v equals to u plus a t. What's our final velocity? 5 meters per second. Initial velocity 2 plus acceleration unknown. What's the time? 60. So 5 is equals to 2 plus a multiplied by 60. That means 5. Take 2 to the left hand side. It becomes 5 minus 2 is equal to 2 has left, so it's no more there. So here we'll be left with 60, a multiplied by 60. Here we'll be left with a multiplied by 60, and that's equal to 60a. 5 minus 2 is 3. 3 is equal to 60a. Now, if 3 is equal to 60a, that also means 60a is equal to 3. Now you can divide both sides by 60. 60 you cancel 60. A is equal to 3 divided by 60. You have 0.05. So we have our A as 0.05 meters per second square. So from here, we now have U, A, T, and V. So now we can select the second equation of rectilinear motion that says S is equals to UT plus half AT squared. Why? Because we are looking for S. We have U, we have T, we have A. We now have our A as 0.05 meters per second square. Our T remains the same, 60 seconds. So we can substitute from here. We have S is equal to, what's our U? 2. Multiplied by our T. T is 60. Plus half multiplied by A. Our A is 0.05. Multiplied by T squared. Our T remains 60. 60 squared. So from this we have 2 multiplied by 60 is 120 plus half multiplied by 0.05 multiplied by 3,600. This is equal to 120 plus, we are applying our board mass. So here, half multiplied by 0.05 multiplied by 3,600, you get 90. 90 plus 120, that will give you 210 meters. That's your answer. There's an alternative way of solving this question. Let's do it. Remember that during the derivation of the equations of rectilinear motion, I came up with the formula that S is equals to final velocity plus initial velocity divided by 2 or multiplied by time. And some people write it as S is equals to initial velocity plus final velocity divided by 2 or multiplied by time. Whichever way you write it, you are correct. You are just finding the average value of the final and the initial velocity and you multiply it by time. So this is the formula we'll be using. Remember, this is a step in the derivation of the second equation of rectilinear motion. And I said we normally use this equation sometimes in line with the other 3 equations of rectilinear motion, provided that the body has uniform acceleration. Since it accelerates uniformly, we don't need to find the acceleration. We just use this formula directly. What's the first step? The first step, you state the values you have. Initial velocity is 2 meters per second. The time is 1 minute. Accelerate uniformly for 1 minute. Convert to seconds, that's 60 seconds. Then we have our final velocity as 5 meters per second. Now we have to calculate our total distance traveled. So we just directly use the formula. S is equals to final velocity plus initial velocity divided by 2. I will multiply by the time. Now let's substitute. S is equals to, what's our V? 5 meters per second. We have 5 plus our U. Our U is 2 divided by 2 or multiplied by our T. Our T is 60. So S is equals to 5 plus 2 is 7. 7 divided by 2 multiplied by 60. In order to make the calculation easier, we just break it down. 2 here, we have 1. 2 in 60, we have 30. 30 multiplied by 7. 1. 30 multiplied by 7 is 210. 210 meters. See, so this is an easier way to solve the problem. Your calculation is usually direct when you use the appropriate formula to solve the problem. Thank you for watching. Please subscribe to our YouTube channel. And our next topic, you'll be solving more complex problems, and that will involve the graphical method. Thank you for watching. Have a nice time.
Oyibo, Ekolowa Oyibo, Oyibo, why you speaking Oyibo? Oyibo, you dey Lagos Oyibo. If I carry you go banana, my guy, you go love Lagos.